For as long as most of us can remember, we've all looked up at the stars and called it the final frontier, right? It's this incredible idea that has totally captured our imagination and inspired generations. But what if the most important frontier isn't way out there, but actually right here on our own planet? Today, we're digging into some fascinating material from industrialdiver.com that poses a really challenging question about where we should be putting our focus.
Okay, so let's just rip the Band-Aid off. The article comes right out and asks it, point blank, is our multi-billion-dollar quest for the cosmos still the right move, especially when we're facing so many urgent challenges right here at home?
Now, to be clear, the source material isn't anti-science, not at all. It's framing this as a massive strategic choice. Do we keep chasing the final frontier in space, or is it time to pivot to what it calls the first priority, our own, largely unexplored oceans? So, to build this case, the article starts with something we can all understand: the money. It takes a really hard look at the costs and the supposed value of space exploration, and it uses a word you sometimes hear from critics: a cosmic boondoggle.
So just how much money are we talking about here? Well, this is NASA's approximate budget for the 2025 fiscal year. $25 billion. It's a huge, huge number, and it really sets the scale for this entire conversation.
But the argument isn't just about the total size of the budget. It's about how that money gets managed. According to the Government Accountability Office, this number, $12 billion, is the cumulative cost overrun across just 15 of NASA's 21 major projects. You know, that's not a rounding error. It's presented as a consistent, recurring pattern. And you can really see this pattern when you break it down into some of the big flagship projects. The Space Launch System rocket for the Artemis program, $2.7 billion over budget. The Orion spacecraft, $3.2 billion over. And the absolutely incredible James Webb Telescope, it came in nearly $6 billion over its original price tag. The source uses these as Exhibit A for systemic financial mismanagement.
But wait, you might say, what about the private sector? Isn't that supposed to make things more efficient? Well, the article is pretty skeptical. It points to the billions of taxpayer dollars going to companies like SpaceX, and it even cites critics who dismiss the whole best value claim with some very sharp language, suggesting it's not the magic bullet for efficiency we might think it is.
Okay, but what about the return on investment? You know, all those famous spin-offs like memory foam or GPS. The source material definitely acknowledges that those benefits are real, but it argues they have a super long, slow burn. I mean, technologies like GPS are decades old now, and here's the key point: they don't really address the immediate, planetary scale challenges we're facing today. And that's really the core of the whole argument for a shift in focus.
So if the argument is to pull back from space, where does all that focus and funding go instead? Well, the article's big proposal is to pivot to the vast, unexplored, and, as we'll see, critically underfunded frontier right here on Earth: our oceans. And this is where the numbers tell a truly staggering story about our national priorities. On one side, you have NASA's budget, around $25 billion. Compare that to the budget for NOAA's Office of Ocean Exploration and Research. It's just $46 million. That isn't a funding gap, that is a canyon. And the funding gap, that huge, has profound consequences. It basically creates a structural barrier. It prevents ocean science from taking on those massive, multi-decade projects that lead to fundamental breakthroughs. You know, the exact kind of projects that have always defined NASA's work. So what are we missing out on? Well, the potential returns here are immediate and literally life-saving. Marine life has already given us compounds for treating cancer, super potent painkillers, and powerful anti-tumor agents. And these aren't just theories. Many of them are already in late-stage clinical trials. This is a direct investment in public health. This also brings us to a really interesting reframing of the whole idea of planetary defense. While space agencies are looking outward for asteroids that might one day pose a threat, the article argues the most immediate threats are already here, and they're climate-related. Ocean data is what helps us predict hurricanes, monitor sea level rise, and secure our food supply. It's how we defend the planet from very clear and very present dangers. Next up, the article shifts gears to the future of resources. It pits the sci-fi dream of mining asteroids against the much more immediate and way more complicated reality of mining our own deep seas. And this comparison is just fascinating. For asteroid mining, the technology basically doesn't exist yet, and we've had missions that cost over $1 billion to bring back just a few grams of material. Meanwhile, deep-sea mining could be a real thing by 2030, with trillions of dollars in estimated value. But here's the massive paradox. The option that's actually feasible comes with known, severe, and potentially irreversible damage to our planet. And those immense risks bring us to a key ethical concept called the precautionary principle. It's a pretty simple but powerful idea. When the stakes are this high and our knowledge is this low, scientists estimate we only have about 1% of the data needed to make informed decisions here. The burden of proof flips. You have to prove that an action is safe before you do it, not try to clean up the mess after the damage is done. So after laying out all the problems and all the potential, the analysis doesn't just stop there and leave us hanging. It proposes a clear 4-part path forward. It calls it a strategic reorientation of our priorities. Let's just walk through them. First, redirect funding away from the super expensive human spaceflight programs like Artemis. Second, refocus our space efforts on what gives us the biggest bang for our buck, cost-effective satellites that monitor our own planet. Third, create a single, well-funded federal office for ocean exploration to finally enable those big, game-changing projects. And finally, apply that precautionary principle. Put a pause on deep-sea mining until a science can actually catch up. And so, in the end, the source material leaves us with this one powerful question. It really challenges us to rethink what exploration even means in the 21st century, and to decide where our greatest discoveries and maybe our most important investments truly lie. Is it in the cosmos above us, or is it in the oceans right here below?